Hi everyone, my name is Anvita Bansal and we are back with another lecture based on strings from your SDE sheet. So quickly let's have a look over it. So the problem is longest distinct characters in a string. So let me just check if you guys are able to see my screen. Perfect. Okay. So this problem gives you a string like this. Okay, you need to find the length of the longest substring with all distinct characters. So what does this mean? Let's have a look. Let me show you. Let me check if you are okay. Fine. Cool. So let's take this example that is mentioned in your test case, which is, let me draw an array of strings. Although it's a string, I'm just drawing it for you to understand what is happening. Okay, let's see. Okay, let it be. So you are given a string like this, GE, geeks for gigs. Let me just write it. For GEKS. Okay, fine. So how can you solve this problem? So the very brute force approach is you can find the substrings, and for each substring you can either keep a track of characters using a frequency array, or you can take a hash map, or you can take a hash set, in which for every substring, let's say you are starting with this index, then using it how many substrings you can find, so on and so forth. And for each substring you can keep a check if that character is found. Let's say currently my substring is G. Okay, and okay, fine, G is there. Now your substring is GE, no repetition is there. But when you are checking for GEE, your hash map will say, or hash set, whatever you have taken, it says that E is already present. So in that case you will evaluate the length of the substring so far, and then you'll move ahead and check for the other substrings, right? Then let's say you check for EE, again it will be of length 1 only. Then you check for EK, all substrings of length 2, and so on and so forth. Okay, so that is one approach. But let's see how can we solve this problem in an optimized way. So I'll directly discuss with the method which your question demands. As you can see that it says maximum expected time complexity is big O of S, where S is the length of your string. Okay, so let's come up at this approach, which is also very simple if you know the sliding window technique. So what is the sliding window technique? One thing, never get scared of the terms that we use while teaching. Obviously we expect, or whenever you are learning or trying to do DSA, it's always expected that you go through all these things. Theoretically also you should be knowing, but whenever you are approaching the question for the first time, don't be scared that you are supposed to know these terms. There many a times you come up with the right approach, but you do not know that this approach has been taken as a topic in DSA, right? So that's the other thing. Fine. What you can do easily is, see, if I keep 2 pointers here, I'm going to take 2 pointers which will always be defining a window size for me. Okay, let's say I start with L from, this is your index 0, this is 1. Let me write the indices: 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fine. Let me start with I at L at 0 and R at 0, where L is the left pointer and R is the right pointer, right? That's how I'm going to use them. So I start both of them starting from index 0. Now what? Also simultaneously I am using a hash map. I'm using a hash map to store the elements and their indices, to know where they are present. Okay, when I'm at the first index, I know it's G is not already present in map, so I add G, and corresponding to it I add its index at which it is present. Then I move the right pointer. So my right pointer is at this position now. Now you check what is s dot caret r. It is e. E is not already present in your map, so you will add this e and the index. Add this e, and what is the index of e? 1. Simultaneously you are also checking what is the length of the longest substring. You want to find length of the longest substring which does not have any repetition of character. So we started from L and R at the same position. In that case, R minus L plus 1, if you do, that's the length of the substring you will get. So that will be of 1 only. Then you move R and you check there is no repetition so far. Again, if you do 1 minus 0 plus 1, you'll get the length of 2. So here I am keeping the track of what is the maximum length so far. It is 2 right now. Okay, then my R move at this position. Now tell me what is first I check if s dot caret R. If s dot caret r, is it already present in map? We'll check into map. Is it already present? So it says yes, it is present, which means, now do you see where your r is? Your r is pointing at index 2, and we know if I consider this as my substring as of now, if I consider this as my substring as of now, so I am definitely not going to get the correct answer because E is repeating itself. So what can be the ideal case? See, what can be the ideal case? Definitely, if I exclude G and take only EE, then also my substring is not going to be the expected substring. I anyway want substring from that position from where I do not have any repetition. So this is the first time I have come across a character whose repetition can be found in the map, right? So that tells me that that character is being found already, and at which position, that is also stored in map. So what you can do is, why not move your left pointer to the next of whatever position that character is present at. So do you see this thing that L was at 0, and now if I move my L to R, not R, basically whatever index your E is giving, that plus 1, which will make it to come at second index, right? So now the new substring that you find which does not contain any repetition of character will be substring whose range is from left to R. Is that clear? You need to understand this thing. I am simultaneously moving ahead in the direction of my right pointer. I am tracking the characters using right pointer, and left pointer is telling me what is the leftmost character that has been included in my substring. Whenever I'm moving my right pointer and I find in my hash map that character has already been found, that clearly means if I tend to include that character into my substring, whichever was going on, that current substring, then definitely I will not get the correct answer because one repetition is found. So why not exclude that character? But if I just exclude that particular character, it will not be a substring anymore. So I need to remove that entire part till where I find that repetitive character. Remove that entire part and now re-evaluate your answer. That is what I'm trying to do. Okay, so now your left and right are at this position, and so far what was the maximum length of the string that you have found with distinct characters? It was only GE. So here I am simultaneously writing the string that I have found so far, which is the longest. Now your range is L to R, where L is E. Okay, fine, pointing to E. Move your R pointer again. Now move your R pointer. One second. Move your, how do we do that? Okay, so I move R at this position now. Now tell me, is K already present in your map? No, K is not present in my map. So I will just add K, and what index it is present at, that also I will add. Now again move your R pointer. So when you move your R pointer again, you will see that it points at 4. S is also not present. You will add to your map. Again you move S here to F, this pointer, this is also not present. You will add it to map here. Again you will add to map here. Again you will add to map because it does not contain. Let me simultaneously update it. So K, then at S index was 4, at F index was 5. I directly moved my R because I was not finding those characters, and I was simultaneously adding those characters which were new to the map, right? O is present at 6th index, R is present at 7th index. Do you see any repetitive character here? No, not yet. Now wait. Now again I move my R pointer. Now again I move my R pointer to the next index, which is at index 8, and I again do the same thing. Ask my map, do you contain G? So map will here return, yes, I contain G, and at 0th index. So wait. What is my current range? What is my current range of substring that I am tracking? So currently my substring is that I am tracking right now is, what is your left pointer pointing to? That is index 3. So my KSFOR is my substring that I have traversed so far without any repetition. Now I am checking for R at index 8. But wait, at index 8, G I find, and it is already present in my hash map. So it says G, and check what is the index of G. It is present at 0th index. But wait, do I need to even worry about it? Because the string that I am considering is only varying from left to R. That is the range that I am using for my substring. So definitely one thing I know for sure, that G wherever it is present or it was found earlier in your string, that is not part of my current substring. It is not part of my current substring, which is ranging from 3 to 7 index, or you can say 8 index as of now. Since I am evaluating for 8, I am not including 8. So you see that G is not affecting my current string in terms of left range, in terms of left pointer, right? But since we have found G at a new position now, so let's assume that maybe we find G once again. So in that case, I will be comparing G's position with the latest recent G that I found, right? So one thing that I need to do again would be updating at what index G has been found once again. So this will become 8. And will there be any change in your left pointer? No change, because already the range of string that I am checking for does not include the previous G. But since I have found G once again in my string, so to evaluate the rest of the string, I need to get the latest index at which this repetitive character is present. That is why your map will get updated, but no change with the left pointer. Okay, fine. So now your string becomes KSFORG, and you move your right pointer to the next index. Moving your right pointer to next index will be at index 9. So does your map contain E? Yes, it does contain E. At what index? So it contains E at index 1. Again, what is the left and right range for your, this will become 9 in this case now. This will be 9. So what is the range right now? It's 3 to 9, and E's index is 1. Is it affecting my current string as of now? No, there is no E found in my current string, and I can easily add the E that I have found now. Will there be any change in the position of left pointer? No change. But since I have found E once again in my map, so I will definitely update the index at which it is found recently. So E recently has been found at index 9. Okay. Next thing, again move your R pointer to the next index, which will be your 10th index. Okay, now wait, let me also update it. Yeah, so I updated it. So far it is this. Now I'm evaluating for 10th index. So I will ask my map, do you contain E? Yes, it says I contain E, and this time the index of E is at position 9. So wait, I was evaluating for range 3 to 9, and I am getting index E at position 9. So one thing is for sure, that my left pointer is going to get affected. Why? Because I am finding E further after my left pointer. So if I go ahead and include this E, which is present at 10th index, my substring will not be valid anymore. So what are you going to do? In that case, you need to make sure that your window is left and right pointer should be such that you do not have any repetitive character. So if you see that it is affecting, and this time the index at which this character is present, it is lying within the range of your current substring. So what should I do? My left is currently at K. Should I move my left to 4? Will it have any change if I want to include E? No, it will not, means it will not make any positive effect, because I still have character which is repeating. So what can I do? Shall I move L here? Shall I move L here? No, no, no. I should move L directly to the index that is where I am finding that character plus 1. Basically, I should move L to whatever index I was finding, that 9 plus 1. That is the index where my L should point to. The reason being, my window size should be in such a way that that character where I found that repetition, right? That should not be included into my current substring. So in order to avoid that character, let's assume this E was, instead of being here, it was here. Let's assume that. So left would have moved from third index to index 8. Why? Because I will omit entire substring where the last character was that repetitive character. Got it? Because I want substring which does not have any repetition. And since I am currently evaluating for index R and I have found that E already in my map, so I will bring my left pointer to that index such that the previous E is not present anymore. Got it? So where will my L be pointing to? So my L will be pointing to index 10 now, right? So my L will be pointing to index 10. This is where my L is. Okay, what is the length of your maximum substring so far? So basically what I wanted to do, I wanted to include E, but I could not include E. The reason being, it will, if I want to include, I should get another substring, and that substring will be E now. This is the substring which I am evaluating for right now according to my left and right pointer, which are pointing to index 10. So far the biggest substring that you found was this only, KSFORGE. Got it? Okay, again go ahead and move your right pointer. So your right pointer is at this 11th index. Wait, this was your L is at 10, your R is at 11. You ask your map, do you contain K? It says yes, but K's index is 3, which does not affect our current window of the substring. So I will not make any change to my left pointer, but one thing will be changed, that is the current index of your K, which is 11. Move your R pointer to the next index, which is 12. So your R is pointing to your 12th index now. Also there is no G here, it was just for your example. Okay, so R is at this pointer, which is index 12. Now you ask your map, do you have this character S? It says I have, and that index is 4. So this 4 index is already not part of my current substring, because right now it is EK, now it is EKS. After E I evaluated for EK, right now it's EKS, and this S is not getting affected by what S I had earlier. I'll just update the current index of S, which is 12, and next your right pointer will be coming at the last, that means it will exceed the length of your current string. So that is all what you have evaluated for, and till now whatever is your maximum length, that must have been stored in some max length, whichever you will be taking, that will be keeping track of what is the maximum length so far. So I hope you understand the problem. This is taking maximum big O of n time complexity, and we are taking a hash map. N is the length of your string, and we are taking a hash map which will keep track of the characters. At max it can take all the characters if they are distinct, so it will take O of n space complexity. So this problem can be solved in big O of n time complexity, which I have shown. Now just give me a moment, I'll just connect my laptop with the charger and be back in a moment. You guys if you have any doubts by that time, you can ask me in the chat. I'll just be back in a moment. Guys, for some reason I am not able to connect my laptop. I don't know why. This power is not working. I'll have a look. Let's move to the code quickly before it shuts down. I've already explained to you, it won't take much time. Let's quickly code the problem now. I don't know why it's not working. I just hope it doesn't shut down. Okay, so we are going to create a hash map integer of character, then it's integer map new hash map. Okay, then you will store your length, let's say int length equal to 0, in which you will return the final maximum length of a substring. Then int left is pointing at 0 index, int right is pointing at 0 index. The window while r is less than, I am taking right pointer, which will go till s dot length, it is s dot length. Okay, so what I'm doing, that let's take char c equal to s dot char at current index r. Fine, I will ask my map, if you contain me, if map dot contains key this character, and also I will ask if my L window, that map that left index, if it is less than map dot get of c plus 1. Only if it is less than that value, that index at which that repetitive character is already present, only then I will move my left to map dot get c plus 1. Otherwise left is at its correct position, right? C plus 1, otherwise it is at its correct position. And then if map does not contain, then I will add that current character and its index, which will be r, into my map, right? And then I will also evaluate length, that is equal to math dot max of current length, and right minus left plus 1 is the length of the current substring that it will give you. And also you are simultaneously within this loop moving your right pointer by 1 index, and let's return length. Let's hope this runs in one go. Let's check it. Let's submit it. So that was all about this problem. Let me check what is the charging right now. It is 6%. Let's see if you guys have any doubts. While condition is, you see, we can solve it. I already explained as I was discussing this approach. You can solve this using a hash set also, but in that case your time complexity will be more than n. The least possible with hash set can be big O of 2n, right? That is the least closest time complexity to this approach. So this approach we are solving in big O of n time complexity. Why? Because if you use a hash set, in that case you do not know at which index it is present. So in that case you will have to traverse over each character. Until you know that where is that repetition. For example, when I am at this position, let's say my r is here and my left is still at this pointer. So my hash set will say, when my right is at this pointer, my hash set will say that e is already present, but where it is present, hash set will not give you that. So for that, what you will do, you will move your left pointer until you find that same character. So now you found one. So what are you doing? Let's say at some point in time your r is pointing to this index, and let's say one more f was found here. So in the worst case scenario, you will be traversing through n this r minus 1th index in your string. So it will be, once you are traversing for right pointer, it will take big O of n time complexity, plus once you are traversing for left pointer, again it will take big O of time complexity. So it will total be big O of 2n time complexity. This is the reason that we are not using hash set for this approach, the approach that we have used. But definitely you can use hash set and solve this problem. I highly recommend, if you are thinking of using hash set, go ahead with that. That should also pass. Okay, that is the reason I took hash map, so that this work of checking where that repetitive character is present will be reduced, because my map will directly tell me that this is the index at which it is present, so you just move one step ahead of that, right? This is the reason I have used it. Any more doubts you can ask me. Great, if you understood. What is the charging now? It's 4%. Let's wait until it becomes 1 and then we'll wrap it. So if you have no doubts, let's wrap this up and see you all in the next lecture tomorrow. Thank you everyone. Bye bye. I hope you understood this approach and why I have directly solved this problem using this approach. That also I have explained, but I highly recommend don't jump up to the solution until you get that intuition. Try with whatever you think of first. Okay. So thank you everyone. Bye bye.